In this talk, we're going to look at some high-level concepts around smart cities and smart transport, and we're going to use e-scooters as an example for that. So that's me. We have a booth here that I'll direct you to at the end of this talk. If you have questions or you want to chat to me about any of these concepts or anything from my earlier talk, please come and find me. I'll be on the booth. So why do we see these e-scooters everywhere? You've probably seen them around your city, and if it's not e-scooters, it's going to be dockless bike sharing, or it's going to be both of those things. Or in some cases, it's going to be car sharing systems. So I've lived in cities that have scooters and bikes, and some of the bikes are e-bikes, and we've even had, in one case, electric smart cars that you can pretty much just park anywhere, pick up, go, and share. What's the motivation for using these? Well, from a city perspective, there's sort of three reasons why cities are encouraging the use of these things. The first, and this is an example from my home city of Nottingham in England, the city aims to be carbon neutral by 2028. So this is an electric tram. It has a carbon neutral ad on it, and it's there to try and take some carbon load off of the transport system. So moving people towards electrified transport is generally a goal that is consistent with that. Also, cities are fairly constrained spaces. We can't really build new roads or deal with the fact that people use large means of transport, such as cars, often with like one person in them. So cities are generally moving towards densification of the use of their existing infrastructure. This means that for car owners, it's generally bad news. So this is an example from London, where you will pay a congestion charge as well as any low emission charge to drive anywhere in the center of the city. This is aimed at driving larger vehicles that take up a lot of space out. So what pours in to fill that space? Denser single-person vehicles or public transport. Then finally, this is a bus, again, from my home city. We have a lot of buses. They're actually running on biogas from food waste, so they are helping towards that carbon neutral goal. What's a bus got to do with e-scooters? Well, the third reason why cities like e-scooters is they fill in what's called the last mile gap in public transport. So if you take a bus somewhere, it's going to drop you off at a bus stop somewhere, or you might have to change routes several times. The last mile refers to that bit between wherever you get off of public transport and you get onto wherever you were going, so like here at RAI or whatever your ultimate destination is. So having things like e-scooters is actually seen to uplift the use of regular public transport services that already exist. So with that as a bit of background, we're going to look at what are the challenges and specifically some of the IoT data that goes on with these systems, and how can a product like CrateDB help you to meet them. So first way of looking at challenges is the different sorts of users that we have. So here we have someone riding the scooter. She's essentially a user of the system. She's probably got an app. And what does she want from the system? Well, she wants to know where there's a scooter nearby, wherever she happens to be, that has sufficient battery to be considered worthwhile for a trip. You don't want to get on one, tag onto it, and then find that it just takes you a few meters up the road and that's the end of it. You need to know something about where things are and what the status of them is. You've then got a second sort of population, the people who help maintain the system. They almost want to know the opposite of the first people. They want to know where the scooters are, but they want to know the ones that are about to need service for some reason or other. They might have a low battery, they might be broken, they might not be talking to the network anymore, there may be some issue with them. They also potentially need to understand trend data. So these businesses are a for-profit thing. So, for example, if lots of the scooters end up in locations where almost no one is going to pick them up and ride them because they're way out in the suburbs, then these people need to know that, relocate them back to areas of high ride starts where they can be utilized more efficiently. Then finally, you've potentially got the scooters themselves. What do they need to know? They need to know information about where they are, and in certain cases, so for example, in one of the cities I've lived in before, there are actual scooter no-go areas where these things are not allowed to operate. They're geo-fenced. So if they enter one of these areas, they generally shut down and tell the rider to go away and go somewhere else. There's also, for public safety, the concept of speed limiting them in some of these areas. So if you're in an area of high foot traffic, the system may be required by the city to speed limit itself. So this generates a lot of data that generally all needs to go somewhere. So we have data from that app, which is both generating the data and taking a feed from it. It needs to know where a good scooter is. Data from the scooters, they're sending a lot of time series type data, usually through the actual app that is their connection to the network while the rider's using them. Data from the people maintaining the system. So when they go and pick a scooter up for some reason, they might start logging more information about what's gone wrong with it and what they're doing with it. And that might over time form useful trending information that we can use to predict maintenance issues. Then finally, some of these systems may have a fourth component. So most of these systems are dockless. Some of them have charger stations. And what do you need to know about as a charging station, or what do people need to know? Is there a free location there? Can I dock a scooter there? Some systems incentivize riders to end trips at charging stations. So whilst they could leave them anywhere, you might get a little bump in credit for the system if you end it at a charging station because you're doing the operator a favor. You're putting it somewhere it can be recharged. So all of this data needs to go somewhere. And what are the challenges with managing that data? Well, first up is volume. So the sheer volume of scooter location requests. Every new scooter you add, it's kind of a big O of N problem if you're familiar with that sort of theory. Every scooter we add generates another stream of events. So one scooter, many events. Those include position updates and battery power updates, and also ride status updates. Is someone using me? Am I being moved without having been paid for? Am I essentially being stolen or messed around with? Those data items come in at incredible speed, and we also need to be able to make decisions based on them at speed. So we need something that can cope with a high ingestion rate of data and has a minimal indexing lag. So it's one thing to be able to receive data and say, yeah, I've got that pretty fast. It's another thing to have it available and efficient for querying. Because if you've received data and it's not available for querying and you've got a lag, you've essentially got a blind spot of however long that is. So this is a near real-time system. People want to know where scooters are like now, not 10 minutes ago, so that when they walk over to it, having reserved it, it likely actually is there and it was there, and they're not going to get frustrated. The other sort of thing we need to do a lot of is aggregating data. So we're generating a lot of data here, mostly time series stuff. The value of an individual record here is actually quite low. So, a given position on a scooter ride is not that interesting. But if you look at lots and lots of rides over weeks, you'll start to learn about where these things go, what the trends are, and perhaps learn a little bit more about where you should place them at the start of the day so that you can get more people on scooters and earning you money. And what we need to avoid is any sort of latency. So from a user's perspective, these things are really easy to get into and really easy to use, and that's great. But if the system is slow or laggy, then they're also really easy to just walk away from and go, you know what, I won't do that. I'll take the bike share, or I'll use a bus, or I'll just walk it, or I'll do something else. Then the other problem we've got with this, or the other set of challenges we have, is we're storing all of this data, and it's all sorts of different types of things. We have a lot of geospatial here. We have a heck of a lot of time series. We might also have document data, so FAQs, repair manuals, information that certain staff need. And we might be doing all sorts of different queries on them. So we're probably going to do some geo and time series queries. You know, I want scooters that are within this area or so close to me and which have battery power for my trip. We might be doing document or vector similarity or even hybrid searches on things like repair manuals or FAQs, or if we've embedded them and got vectors for them, trend information about scooter usage and subsequent breakdowns, so we can do predictive modeling. And we generally don't know what these sorts of queries are going to be until we've operated the system for a while. So we have quite a lot of challenge with how we organize and index and manage this data. So with a lot of background there, so what is actually CrateDB? It's a database that is hyperfast and open source. It's for real-time analytics and hybrid search, but also a lot of other things. It looks roughly like this. What we're aiming to provide is a single data store for all of your different types of data that can be queried using one thing, so SQL. So if you went to my earlier talk, you'll have seen that we have all of these different types of data. So relational tables, things in Crate are organized by tables, but those can contain document data, vectors, geospatial, time series, the whole thing. You can query all of those with SQL, and you can put data in there using either the Postgres wire protocol, so tools that you're familiar with already, or for IoT, we also have an HTTP endpoint, so you can just post stuff in there from devices that don't necessarily run a Postgres client or don't want to deal with complicated protocols. The database scales horizontally, and it's also available in the cloud, on-premise, and on the edge. So you can run it on anything from a hyperscaler cloud down to a Raspberry Pi. So let's quickly look at what some data modeling for this problem would look like in Crate. So we're going to have a table here that describes our scooter fleet. What we've got here is basic information about the scooters. So an ID of the scooter, its current battery percentage, whereabouts it is, which is a geo point, so a geospatial structure. And then in there, I've got a couple of what you see as object dynamics. So CrateDB has a schema, but it's also extremely flexible. So what we're doing here is saying, we know that scooters are going to have a manufacturer, and that's a sub-object, and that's going to have a make and a model and their text, and then we're going to have a firmware and an in-service and all of this stuff. But we don't necessarily know that that's everything we want to store about scooters. So what will happen if we insert data in here with more than those fields is the schema will grow accordingly. Everything in this will be indexed automatically by CrateDB, so all queries you can expect to hit an index and be fast. This is good for our problem of we don't know what the queries look like. Then similarly, we might have a large table of ride events, so time series events that happen during a ride. Usually these are going to relate to a given scooter, and they're going to have a timestamp and some ID for what sort of event it was, and what the battery life of the scooter was, where it was, etc. And we're going to want to manage these carefully. So what I've done here is partition this table by a field called day. So we've taken that timestamp, rounded it up to the nearest day, and we'll build a table that's made out of essentially subtables for each day. That enables us to do very quick aggregations because we'll know for a time period which subtables to consider and which ones to ignore. And then I've also down the bottom said that we want a dynamic column policy. So we don't necessarily know everything we're going to store here yet. So if we receive a ride event that has columns that aren't these columns, then what will happen is the database will expand the schema and infer the data type for that and start adding and storing more records with those columns. It will also automatically index them unless you tell it not to, which means you can expect queries against that to be fast. So I also said earlier that we might have some sort of semi and unstructured data in there. So we might have manuals, or we might start creating vector embeddings for usage patterns or whatever it's going to be. So in CrateDB, you can perform a couple of types of searches. We can create data inside tables, and we can mix and match what we've got going on here. So imagine we had some sort of FAQs, we have questions and responses about the system. Some of our users might want to ask it questions through the app. We can store these in two ways. So here I'm storing them as a float vector, which means I've run them through, in my case, I ran them through OpenAI's embedding model. And we can then perform KNN vector similarity search on those to find things that are like the question semantically. CrateDB also uses the Lucene search, so we can do a more keyword-based search by saying I want a full text index. Here I'm creating a composite index over both the question and the response. So how do we query stuff once it's in there? We're going to use SQL for absolutely everything. So unified query interface, no matter what type of query or what type of data. So simple query that helps with the users. We want to find scooters that are nearby us and which have sufficient battery. So here's some scooters that are in Long Beach and have more than 30% battery available. Equally, we might, as a maintainer, want to do some sort of time series queries. So simple query here. As a maintainer, we might want to know when does the scooter hit its lowest battery point of the day, because it helps us with planning and charging and taking these things out of service. So here I'm using a function min-by that just gives us the minimum value of a certain field in a table. It gives us the time at which a minimum value of a certain field was achieved. And then we can see when the scooters are starting to get low on battery. We can start to analyze this trend over time, and this sort of aggregation is incredibly efficient. So we can also do search and vector similarity queries, again with SQL. So I showed earlier how you create those indexes and store those embeddings. So for a simple Lucene type search, I can look for facts that involve driving license. We built a composite index, so that'll be in our questions or our responses. And I can also do KNN nearest neighbor vector similarity searches. So I can say, just by changing the column name and the function name here, do a more semantic search. So things that might talk about the concept of driving or licensing or things associated with that. You can, of course, combine these in a single query by just basically mashing these two queries together, getting two scores, and then deciding what you want to do with those relative scores. So where does CrateDB fit into an ecosystem? The answer is it's an easy fit in there because we are a SQL database. So if you have tools or systems or programming libraries that use SQL and understand the Postgres wire protocol, we fit right in there. So you could use, for example, Grafana to visualize stuff. You can use Kafka as a streaming data source. We also have an HTTP endpoint, so you can post things right into there from, for example, I do this from Raspberry Pi Pico devices with MicroPython. It's really simple. Those devices can wake up from a long sleep, do a single HTTP post without having to worry about any sort of session. So we fit into all sorts of things. So in summary, where does CrateDB fit with IoT? Well, you're going to want to store all sorts of different data, and we're a great fit for that. You're probably going to be evolving your project as you go, so having dynamic and flexible schemas, so enough schema when you need it and enough flexibility when you don't. Good fit for that. We have an incredibly fast ingestion support. We scale through adding extra nodes. Each node does not have a specific role. It just gets added to the cluster and spread out accordingly. And we index everything, so that time to query should be minimized. And also, time to query anything you want should be minimized. You don't have to go and get someone to build an index, and then your queries become fast. So you're going to want to query this stuff. We do it all with SQL, so you've got a single interface for that. Again, everything's indexed. We're optimized for aggregations. We do full text and vector similarity search. And distributed architecture means you can just keep adding nodes as your solution grows. Then what use cases do we support? We talk a lot about real-time analytics. We work well for things like fleet management. We have companies doing smart manufacture and managing both the warehouse process of the manufacturing and the machines that enable that process. So the lifting machines, conveyor belts, etc. We get used for providing data source for predictive maintenance and also building digital twins. And I'm out of time, but if I can leave you with one thing from this talk, it would be please go to learn.cratedb.com and check us out. We have free online video courses. You can learn about the product with some data from the city of Chicago. So sticking with that smart cities theme. Then finally, the best way of asking us questions is come find us at the booth where we can talk to you at length and we can point you at the right person. So we have some live demos going on, including one very shortly. So if you'd like to pop over to 148, we'd love to see you. Thank you.